This video will illustrate the chemical cause for the change in color of a light-emitting diode, or LED, in the presence of a temperature change. We'll be using liquid nitrogen to cause this temperature change to 4 different colors of LED: red, blue, orange, and yellow. An LED light has a diode containing positive or P-type semiconductors and negative or N-type semiconductors. The P-type contains holes, which are positions where electrons are missing from a certain orbital, leaving a net positive charge. The N-type has extra electrons, so when the circuit is completed with the diode, the electrons and holes come together from opposite sides. The holes that fill up quickly are in the middle, and this area is called the depletion zone. The battery does work to move the electrons from the N-type through the depletion zone to the P-type. The energy difference between these two types is what's known as a band gap. Thus, this energy released from the electron is given off as a photon, which produces the color you see. When the LEDs cooled in liquid nitrogen, the electrons in the N-type semiconductor have lost thermal energy and are therefore at a lower energy state initially. The depletion zone physically gets smaller because the atoms of the semiconductor move slower. Because of Coulomb's law, the shorter distance between the N and P-type semiconductor causes a greater attraction between the electrons and the holes. This results in light of higher energy or shorter wavelength being released. This means that a more energetic photon is released, resulting in a color change of the LED. From this equation, we can see that energy and wavelength are inversely proportional. This means that the increase in energy caused by the cold temperature will cause a decrease in wavelength of the photon emitted. Knowing that we are expecting a decrease in the wavelength of the color emitted to the next color of highest wavelength, what color change do we predict to see in this normally red LED light?
Nice. It turned orange. It is orange.
If you said orange, you're right. What about this normally yellow LED? You're correct. It changes to green. What about this normally blue LED? Great job! It turns purple. So, as we saw in the videos, the LED light changes color. To explain how this works, we first explored how an LED would work at normal temperatures. The N-type and P-type have electrons and holes that move toward each other when it is in a circuit with a battery. The movement causes the emission of energy in the form of a photon. Now let's review why the color changes. The liquid nitrogen is naturally cold, and what it does is that it makes the atoms in the semiconductors move slower. In turn, this decreases the size of the depletion zone, which leads to a light of shorter wavelength to be released. Therefore, a color change has occurred. That's all today, guys.